Hi, everyone. Good afternoon. My name is Alyssa Sinaway. I'm an architectural specialist here at ARDEX. I just wanted to take a minute to say thank you for joining us for today's Learn from Home webinar. Today's presentation is AIA certified and will count for health, safety, wellness credits, although you don't have to be an AIA member to participate. The certificates for today's webinar will be distributed by email early next week. If you provided an AIA number during registration, we will report the credits on your behalf. In today's presentation, we will be covering adhesives and navigating high relative humidity. This is a new CEU course for us, created to address one of the biggest issues in flooring today. I'm going to go ahead and turn it over to our presenter, our Director of Technical Services, Mr. Seth Pavarnik. Seth has been with ARDEX for almost 30 years and has worked with many industry associations and standards organizations. We will hold a Q&A portion at the end of the presentation, so feel free to submit your questions in real time in the questions panel. So Seth, go ahead and take it away.
Thank you, Alyssa, and thanks to everybody out there for taking a little time out of your day to spend some time with us here at ARDEX. In the AIA that we're going to conduct today, we're going to talk a little bit about the chemistry of adhesives, the types of adhesives that are out there, some of the factors that you got to look at for successful installation, problems due to moisture, sources of moisture, where's that moisture come from, testing for moisture, and then we'll spend some time on RH and pH to make sure we have a good understanding of that. Not only high RH, but how pH may come into play. There's a process called slab curl relaxation that I want to spend some time on too. This is something that you see on occasion out there in the industry, and it can kind of get blamed upon the flooring installer when it's actually a result of excessive moisture. So I want to make sure everybody understands that, and then we'll kind of wrap things up with regard to remediating moisture. So the flooring adhesive industry, giving you a little snapshot here with regard to environmental regulations. Regulatory changes have demanded formulation changes for many of the adhesive manufacturers. You look at the adhesives that were out there, and you go back 20 or 30 years. There were probably more so into the the 80s, maybe early 90s, is when the solvent-borne adhesives went away, due to these regulatory changes, getting away from the hazardous type adhesives that were out there. The other thing that was a big change is the flooring structures. The backing structures such as PVC being replaced with polyolefin, glass backed flooring, recycled materials, and it makes it a little bit difficult for an adhesive manufacturer from the standpoint of, years ago they could make an adhesive that pretty much would cover all flooring from a broad sense. And as we get into these more specialized backings, there's a lot more testing that has to be done as a part of the developmental stage of specific adhesives. So looking at the chemistry, the term binder is basically the base polymer that is holding the floor covering to the substrate. Okay. The strength of the material is coming from this binder. The overall performance of the flooring is coming from the specific binder, holding that floor covering to the surface. As a part of the chemistry, you also have petroleum processing oils and resins. Some of these materials will soften the polymers, making them more pliable. They will enhance the dry tack, how tacky the material is as it goes dry to the touch for those pressure sensitive type adhesives. There's also preservatives and fungicides in there in the adhesives as a part of the chemistry, the constituents, the adhesives, and that's to stop things from growing in your pail of adhesive. Majority of the glues that are out there today are waterborne products. They have water as the carrier, and you have that bucket of adhesive, and it has water in it. They put those preservatives and fungicides in there so things don't grow in the pail. As a part of the chemistry and the makeup of the adhesive, there are filler materials in there, so it's not just 100% binder. In addition to the water that may be in there, you have fillers in there too, clay, carbon black, calcium carbonate, which is basically limestone, silica, not silica sand, but more like silica fume, powder material. There's also rheology modifiers in there, depending on what you want the viscosity of the adhesive to be. Maybe a flooring adhesive is a little bit more of a lower viscosity material compared to a wall-based adhesive, where you want something that's heavy-bodied, a little bit more heavy-bodied for applying it to a wall, so that gravity isn't taking over and having the adhesive come off the wall. There's also antioxidants in there as well. These materials retard the oxidation process, the natural oxidation process. So those antioxidants in there can help extend the life of adhesives. Some of the adhesives out there, maybe the latex is out there. You may see a 1-year adhesive, a 5-year adhesive, maybe even a 10-year adhesive. And in addition to the binders used in those adhesives, antioxidants play a role in the length of the adhesive, the warranty life of that adhesive. There's also light and heat stabilizers in the adhesives, so that they're not, affected by light. High heat can have a negative effect on the adhesive as well. So you got those types of constituents in the formula. And then finally, you have cross-linking or vulcanizing agents that help in the curing and the chemical bonding of the adhesive. But I don't want you to misunderstand, curing and chemical bonding, not in the sense where you have, traditional chemistry happening where A is reacting with B. There'll be cross-linking and vulcanizing agents in there to help the material in the cross-linking, the polymer, just the polymer itself, and coalescing to hold that floor covering together. So let's take a look at the adhesive family tree. A variety of different types of adhesives out there. Starting off, we'll touch with solvent-based and water-based. And you see that I have, the word born in parentheses. A lot of people in the industry reference these products as water-based or waterborne. A little bit of a pet peeve of mine because, if the product is water-based, that means the main chemical is water. And from an adhesive standpoint, we're certainly not using water to adhere the floor covering to the substrate. We're using a polymer like an acrylic. So technically, it would be an acrylic-based adhesive that maybe water's the carrier. So it would be a waterborne acrylic. Acrylic's the base, water's the carrier, hence the name waterborne. We'll also talk about urethanes. There's single component as well as two components where you're mixing an A and B and they're reacting chemically. And then you also have an epoxy. We'll discuss those as well. Within the waterborne family, we're going to touch on SBR adhesives, styrene butadiene rubber adhesives, as well as the more modern day technology acrylic materials. All right, so back to solvent-borne. And you see that I don't have that as solvent-based. The solvent-borne adhesives, while there still may be some out there, such as like a contact cement, that's a solvent-borne adhesive. But basically the solvent, no matter what that solvent is, it's the carrier. It could be mineral spirits, it could be acetone, it could be naphtha, hexane. There's a variety of different solvents out there, but the solvent's the carrier that gets the polymer, the binder, to the floor or the wall if it was a wall adhesive. And then once that solvent flashes off, then the polymer can coalesce and bind the floor covering to the substrate. Okay, that's how that works. Now, there's advantages and disadvantages to the solvent-borne adhesives out there. Can provide high early strength. I mean, there are solvents that flash off in a very short period of time. I mean, there's exterior carpet adhesives out there that can be waterproof in a matter of a couple of hours, and that's because the solvent flashes off so quick. There's also a variety of different open times, and that has to do with the solvent as well. What type of solvent are you using? Something that may flash off very quickly, such as acetone. A lot of times you'll see acetone in a contact cement because in a matter of, 5-10 minutes or so, that contact cement is flashed off to the point where you can take, one side of the material and the other substrate and push the two together to get bond. Another advantage here is the solvents can easily wet out some of the difficult backings. And certainly from a high humidity standpoint, being that we don't have water there trying to evaporate, it's a solvent. The solvent can, flash off in high humidity environments, and in many cases allows to be used in between two impervious surfaces. Your typical waterborne products are typically not suitable for in between two impervious surfaces because there's nowhere for that water to go. Disadvantages, certainly the flammability. I mean, if you have an acetone product that's the solvent carrier, I mean, certainly very flammable. The toxicity as well. And you certainly have a strong odor in most cases and very high VOC levels in your solvent-borne adhesives. Just about all of your adhesives, present day, majority of your adhesives today are made with water, hence the term waterborne adhesive. Water's the carrier. Water is taking that and getting that acrylic to the floor or the wall. Water's getting that SBR latex to the floor or the wall. Once the water flashes off, then the adhesive can start to coalesce and bond that flooring to the substrate. Some of the advantages of waterborne adhesives, low and in most cases present day, no VOC levels, non-toxic, non-flammable because you got water in them, not solvent, and they can be cleaned up with soapy water before they're dry. Just because they're made with water, that doesn't mean when they're dry that water can emulsify the adhesive. Typically water does not affect adhesive, once it's dry. So in the wet state, whether it's on your trowel or you have to clean it off, maybe a door jamb or something that it got on by accident with soapy water, you can easily remove the wet adhesive. Some of the disadvantages out there, more dependent on temperature and humidity because you're dealing with water here. So cooler environments and low airflow, it's harder for the water to evaporate, so it takes the adhesive a little bit longer, to set up. Okay. Waterborne adhesives are typically not used between two non-porous surfaces or two impervious surfaces because there's nowhere for the water to go. There may be some adhesives out there that if you have a non-porous substrate, you got basically a non-porous backing. They may go with a smaller notch trowel and a longer open time to get a majority of the water out. Or they go to a pressure sensitive where it's dry to the touch, and then you apply the floor covering at that point. A lot of the new technologies here are protected from freeze thaw. They're freeze thaw stable, but only to certain temperatures and only for a certain amount of time, being that it's a waterborne adhesive. Some of the technologies that we mentioned, one, SBR, these are styrene butadiene rubber adhesives. These are waterborne, as mentioned. Some of the advantages, you got a wide range of SBR polymers. Your typical clear thin spread adhesive for VCT is an SBR latex, waterborne adhesive. Lot to choose from. They're pretty economical and high performing. Some of the disadvantages is the SBR polymers can oxidize over time. Some of the higher performing adhesives that have a longer warranty period have high amounts of antioxidants in that formula so that they can perform. The SBR latex can be susceptible to plasticizer migration. Plasticizers are added to vinyl floor coverings to make them more pliable. make them more flexible. But over time, those plasticizers can leach out. So it's critical for the adhesive to be able to resist plasticizer migration. Now, while an SBR adhesive is suitable for VCT, vinyl composition tile, and that's a vinyl material, obviously, there's a majority of that material is calcium carbonate or limestone. Maybe 50 to 70% of the makeup of VCT is limestone. So SBR polymers are just fine for that. But you get into solid vinyl, homogeneous or heterogeneous tile sheet, you typically do not use SBR adhesives for those types of flooring. Another disadvantage, costs are rising due to worldwide availability. So you see a lot more of acrylic technologies present day, and that's one of the reasons for that. We'll look at some other reasons here in the next slide. Acrylic adhesives, made with water. Water's the carrier, acrylic's the binder, offer a very high resistance to plasticizer migration. They're a high-performing, high-strength type of adhesive. That's your new, the new technology adhesive that you see on the market are acrylic materials. Disadvantage, typically more expensive than your SBR adhesives. Okay. There are urethane adhesives out there. Could be a one component, could be a two component. Your traditional urethane adhesive for wood flooring, whether it's engineered wood plank or some of the, parquets or some of the solid shorts out there, that's a single component urethane. Moisture is the catalyst. So moisture, the ambient moisture and some substrate moisture will catalyze that adhesive to develop strength, compared to the two component urethanes where you got A reacting with B that chemically creates a chemical cure due to the chemistry, due to A reacting with B. You'll see a lot of the two component adhesives in commercial applications, high performance, underneath hospital beds and applications like that, where you need a higher performance adhesive. Another high strength adhesive is epoxy. Again, a two component material, A and B. A is mixed with B. A is reacting with B, chemically curing. Again, a high strength adhesive, typically used in high performance applications, rolling loads, point loads, hospital rooms, corridors, things like that, where you have resilient tower sheet but need that high performance and more indentation resistant adhesive. So let's take a look at the evolution of flooring adhesive, just to kind of have you understand where we started and how we got to where we are today. You go back into the early 1900s and there were waterborne pastes out there on the market. Move into the 40s through the 80s and you saw the solvent-borne adhesives, typically an asphalt base. Solvent is the carrier. Your traditional cutback adhesive is a solvent-borne asphaltic material. Got its name cutback because many years ago they used to take that asphaltic material and cut it back with gasoline, stuff like that. It kind of got its generic name as cutback. It just kind of stuck with the adhesive. But we moved into the the late 80s, into the early 90s up to present day. We got rid of the solvents, more waterborne adhesives, waterborne SBR and waterborne acrylic adhesives. Your wood flooring adhesives transitioned into the water-based adhesives. That was a very difficult task for the adhesive manufacturers out there. There was a lot of pain that was undertaken going for the traditional, 111 Trichlor F wood flooring adhesive, transitioning from that solvent-borne type adhesive into the waterborne. A lot of pain with, transitioning, and those waterborne adhesive in the early days didn't perform so well with your wood flooring products out there. Present day, a lot of great technologies on the market. And it was also at that time period they transitioned into a urethane adhesive, moisture cured urethane, single component for wood. Adhesive installation considerations. Don't want to spend a whole lot of time here. We certainly could, but we got a lot to go through here. But I just want to make sure that you understand what we have to keep in mind when we're looking at selecting adhesives and floor coverings and building an installation system. Certainly open time, there are adhesives that are two component that you drop in as a wet set immediately. Even the single component wood flooring adhesives, no open time, but your waterborne adhesives in most cases require an open time, maybe 10 minutes, maybe 15, maybe 20, allowing some of that water to flash off. Working time is something else that you got to consider. Flooring application as well as rolling um, where required, must be completed during the recommended working time. You got to understand that working time so you can be successful and you get the flooring in, make the adjustments necessary within that working time and roll it within that working time so that the adhesive doesn't get too set for those things. Certainly type of adhesive is a consideration. Traditional is wet set where you comb it out and it's either immediately drop the flooring in or a small open time. But present day with the acrylic technologies, you see a lot of pressure sensitive where you go dry to the touch. And pressure sensitive installations are not just for carpet tile anymore. You got pressure sensitive permanent installations for vinyl tile, vinyl plank, and even vinyl sheet for that matter, as well as other floor covering products. Transitional is a newer version. It's somewhere in between that wet set and pressure sensitive where you're getting a little bit of transfer, but you're giving the adhesive a little longer working time. So there are adhesives like that you have to take into consideration. And certainly method of application. Traditional has been trowel where you meter the adhesive with a notch trowel, but you're seeing popularity with spray adhesives out there. And more present day with roller applied, where you're just dipping and rolling, making sure that you roll the adhesive out into a certain square footage and allowing that adhesive to go dry to the touch and dropping the flooring in. So different methods of application. Certainly service conditions have to be taken into consideration. Rolling loads, point loads, type of traffic, ambient conditions, return to service time. Can we return this to service immediately, or is there a 24 to 48 hour wait time for the adhesive to develop strength before you return it to service? Chemical exposure, maintenance issues. We've got to look at all those different service conditions when selecting an adhesive with a specific floor covering. And certainly the floor covering, you got to look at that as well. When selecting an adhesive, I mentioned before the backings, the underside of the flooring, that bonding area, the backing, as well as the bonding surface for that matter, using the right adhesive for what you have at hand. You got to look at the dimensional stability of the floor covering and what type of adhesive is needed for the success of that floor covering. Looking what the manufacturers recommend with the type of adhesive as well as the application of that adhesive. The geometry is critical as well. Are we doing a tile or a plank, or are we doing sheet? That plays into adhesive selection and overall performance. Certainly when you're installing the floor covering, you got to look at orientation of the floor covering, whether it's machine direction or cross direction. The installer's got to pay attention to that. We got to look at indentation resistance depending on where this floor covering is going to be used, and certainly susceptibility of telegraphing, through that floor covering. Okay. Some other considerations, certainly the substrate, the flatness of the substrate, the smoothness of the substrate, so that we're not seeing imperfections telegraph through. The porosity, okay? If you moisture mitigate, the adhesive and floor covering may require a blotter layer, a cementitious blotter layer over the moisture mitigation material of at least an 1/8 inch in thickness. Most waterborne materials need a porous substrate for the water that's used as a carrier in the adhesive to absorb down into that substrate. So you got to look at that. Certainly with any installation, We need clean, we need dry, free of contamination. And we certainly have to pay attention to excessive moisture and pH. Follow the floor covering and adhesive manufacturers with regard to that. So speaking of moisture, good segue to get into here. Cost of subfloor moisture, billions of dollars spent each year because of flooring failures from moisture in concrete, and otherwise perfect installation will fail if the moisture issues are not addressed. Okay, why so many problems now? One application might be warehouse conversions to office space. Warehouse was built, 30 years ago, no vapor retarder underneath of it, but it didn't need to have a vapor retarder because the ground moisture can just come up through the slab and evaporate into the air. Now, we take a section of the warehouse, 4 walls, we acclimate it, we have no vapor retarder underneath there. We're getting issues because we got excessive moisture from the ground affecting the performance of the adhesive and the floor covering. Another reason is more fast track construction. You dig a hole, foundation, 4 walls and the roof, and 30 days, 45 days later, they want store open for business and getting some return on their investment. Bottom line is with fast track construction, we're not giving the concrete enough time to dry for successful flooring installation. You go back a few years and the slab construction practices changed to eliminate the vapor retarder. However, back in the early 2000s, ACI put out a document that said all concrete to receive moisture sensitive floor covering that's on grade or below grade needs to have a functional vapor retarder underneath it to stop ground moisture from coming in and affecting the performance of the floor covering. And then finally, the whole industry has a greater understanding and awareness of moisture issues. You go back 30, 40 years, it could have been a moisture problem, but everybody was pretty much looking at the failure saying, installer must have screwed up in some capacity. We all have a better understanding and able to identify problems due to moisture. Okay. So we'll spend some time on moisture, excessive moisture, as well as pH and what it does to finished floor covering. Certainly with excessive moisture and pH, we're not high pH, we're not seeing good results as you see in the pictures here. One thing I want to make clear to everybody that it's not just moisture, it's not just pH, and we're going to spend some time on this. It's the two together that make it detrimental. And you can do your own test here. Just about all of your adhesives nowadays are made with water, but that doesn't mean the water is going to affect them after the floor covering is installed and the adhesive is set. You could comb some adhesive out on a board, let it cure, dry, it's hard, pour water on it, and water is probably not going to do anything to it. But if that water was very alkaline, had a very high pH, it could emulsify the adhesive like you see in the pictures here, where it turns the glue back to the liquid state. That's a combination of excessive moisture, liquid material, condensed liquid water, and high pH. And we'll spend some time on that. Modes of failure due to excessive moisture. Certainly adhesive breakdown. If we're at the point of condensed liquid and we have high salts from the concrete that are very, very alkaline, it can break down the adhesive like you see in the picture here and in the pictures on the previous slide. Looks like the adhesive was wet set and immediately pulled back, but that's cured adhesive that has emulsified due to condensed liquid that's very alkaline. If you have adhesive that's emulsified, certainly the adhesive can start oozing. It certainly equates to disbonding. If you got liquefied adhesive underneath the floor covering, it could cause microbiological activity. It's a big fancy word for bugs underneath your flooring, things that are growing. And if you got things growing, it can certainly contribute to staining of the flooring. And finally, efflorescence. A big word there. We'll spend a little time on that word. Some people have difficulty pronouncing the word efflorescence. We're going to come back to that though, so keep that in mind. Okay, sources of moisture. Variety of different sources out there. Certainly, mixed water from the concrete is a source for moisture. You know, they put a lot of extra water in concrete so that it can come down the chute. You can screed it, you can float the concrete, you can finish the concrete. If we only put enough water in concrete for the chemistry, you could never place it. So there's extra water in there, which means we pour concrete today, we're not putting floor covering on concrete tomorrow or next week or even next month in most cases. I mean, it could be several months before that concrete's dry enough for floor covering. So that's a source of water that we got to pay attention to when installing flooring. You know, outside you could have irrigation, you can have planters on the outside of the building, which can cause, you know, groundwater to infiltrate underneath the slab and cause problems. Um, you know, you go up to the 23rd floor of a building and say, how can we have an issue here? Concrete slab's 20 years old and we got failure due to moisture. Well, there's got to be some sort of other source, and in most cases, it would be a broken pipe that's in the slab. Okay. However, I've seen swimming pools on the, you know, upper deck floors of buildings, you know, third floor, fourth floor, and all that humidity in that space could cause, you know, moisture issues for the floor covering on the next floor above it. Okay. The building doesn't, or I'm sorry, the moisture does not have to be always from the bottom. Certainly from the top, you know, whether it's building uses that are introducing humidity to the airspace, or whether it's the maintenance guys that are basically, you know, dumping water on the floor and mopping the floor, and you know, you got top-down moisture, top-down water, you know, going into the floor covering in the joints of the flooring, things like that. So many different sources of moisture. The biggest one we see out there is the ground. You know, especially in a renovation standpoint for a slab on ground or below grade. If you don't have a vapor retarder, then ground moisture will migrate up into the concrete and affect the performance of the finished floor covering. So let's transition over to moisture testing. Calcium chloride testing here, you know, a test method for testing for moisture in concrete. It's been around for a lot of years. Small container of plastic container of calcium chloride, which has a very high affinity for water. With the lid on it and the tape on it, you pre-weigh that container pre-test, and then upon proper preparation and opening up that container to expose the calcium chloride, you put that open dish on the concrete floor and put the dome cover over it with the double stick tape, and you let that go for 60 to 72 hours. And any moisture emitting from the concrete gets absorbed into the calcium chloride. And at the end of the test period, 60 to 72 hours, you cut open the dome cover, you carefully remove the calcium chloride container, you know, being careful not to spill anything. You put the lid back on, tape back on, and you reweigh it as a post-test weight. And basically, it's the difference of weight of that container, pre-test to post-test, with a mathematical equation that will equate to pounds of moisture, literally pounds, you know, literally pounds of water emitting out of a concrete slab, I should say 1,000 square feet of a concrete slab in a 24-hour period. And then your manufacturers would have maximum emission levels, you know, via the calcium chloride test. The other one, and one that has really gained popularity in recent years and is used quite frequently, is the relative humidity probe. The ASTM standard is F2170. The ASTM standard for calcium chloride is F1869. I don't think that I said that previously. But in essence, you know, we've always been able to, or for a lot of years, have been able to test the ambient relative humidity, and that's done so in a percentage standpoint. And we're doing the same thing with moisture in concrete. We're putting a probe in the concrete and establishing the humidity in the concrete in the form of a percentage. And it's very common to put the probe, let me back up. Well, I'll say this, while you can test humidity at the bottom of the concrete, the middle of the concrete, the top of the concrete, you know, you can profile the depth of the slab to see what the humidity level is. it's very common to put a probe in at 40% of the slab thickness. And the reason being, if you have an open slab, nothing on the surface of the slab, you always have a higher moisture level at the bottom and a lower moisture level at the top because the moisture is evaporating out of the top of the concrete. So if we go in with the probe at 40% of the depth of the concrete, we can predict what the moisture will be top, middle, or bottom once floor covering is installed and that moisture redistributes. So in other words, when you put something over the floor covering, over the concrete, such as floor covering, the moisture is not evaporating out of the concrete like it would. Moisture likes to be within equilibrium itself, so the moisture in the concrete will equalize. And while there's a gradient in that picture there, where we have 99 at the bottom, 85, towards the middle top, and then 74 at the top, that moisture gradient will average out once you put something on the surface of that concrete. So that we're more like, 86 at the bottom, 85 at the middle, 84 at the top, once the moisture equilibrates. So with an open slab, going in at 40% depth, we can predict what the humidity level will be in the slab once that slab is covered up and the moisture re-equilibrates. Many floor coverings and adhesives today can withstand very high RH limits, mid 90s, high 90s. There's some floor coverings that actually go to 100%. Okay. With moisture tolerances increasing, it's even more important present day to understand pH as it relates to this very, very high RH. So that's something that we're going to spend some time on here today, because I want you to all to understand pH, because with these high RHs that were allowable, it's just more critical to understand pH, and we're going to explain why. So any concrete slab out there in the world has natural levels of sodium in it, potassium, chlorides, sulfates throughout the slab, top, middle, bottom. Okay, you look at sodium, potassium. I mean, they're small amounts. 800, maybe 200 to 800 parts per million. In the concrete. The chlorides might be 10 to 100 parts per million. Okay, sulfates are a little bit higher, but in essence, there's acceptable levels of these salts in concrete. With excessive moisture, the moisture will take those salts as the moisture is emitting through the concrete. It'll take the salts along with it and deposit them at the surface of the concrete, which now allows heavy concentrations of these salts at the surface of the concrete. Higher concentrations of sodium, potassium, chlorides, sulfates. Okay, these salts in concentration are very alkaline. They have a very high pH. Okay, so I want you to remember that. I told you we were going to come back to efflorescence, and in doing so, I want to make sure that we are understood on the word efflorescence, because I actually wish I had $5 every time somebody called me and said, I have an effervescence problem with my concrete. I'm like, wait a minute, your concrete has a drinking problem? What's going on here? So effervescence is the bubbly in champagne and in beer and pop, Alka-Seltzer, like you see in the picture below. That's certainly different from efflorescence, but words that get mixed up all too often. I actually had a guy call me up one time and said he had a phosphorescence problem with his concrete. And I'm thinking to myself, wait a minute, you're telling me your concrete has glowing rocks in it, glowing aggregate? What do we got going on here? So we're not talking about effervescence. We're not talking about phosphorescence. We're not talking about fluorescence. We're talking about efflorescence. Okay. And efflorescence is the process, going back to the previous slide there, the process of the moisture taking those natural salts and driving them up to the surface of the concrete. Okay, that's efflorescence. Um, these salts, these sodiums, potassium, chloride, sulfates, I mean, they look like salt. And, in a lot of cases, you don't see them. And maybe some of you on the call have never seen them. But here's a couple of pictures where they're pretty extreme. You look in the left picture, this is a VCT, and you got salt formation, coming up between the joints of the tile. In a well, geez, I was going to say stalactite, but I can't remember which one's from above and which one's from below. So it's either a stalactite or a stalagmite. I apologize for forgetting my ninth grade learning. Anyhow, on the right side, they pulled back the flooring, and you can certainly see white efflorescent salts on the surface of the concrete. And those salts have a very high pH. So let's spend a little time on pH itself. So I asked the question to everybody, and you don't have to answer, but what does pH stand for? And I know you're all thinking you know exactly what it stands for, and you're all absolutely right. It stands for Planet Hollywood. Not. All right, I will leave the comedy alone. I will stick to my day job. pH. The pH actually does stand, it is an acronym. It stands for the power of hydrogen or the potential of hydrogen. And you're basically measuring the hydrogen ion activity in a liquid such as water. It's indicating the level of acidity or alkalinity. And we're going to spend some time on that so that we all understand, things that are acid-like and things that are alkaline. Okay. The key thing that I want you to remember here is pH is the measure of hydrogen ions in solution. Okay. The key word solution. Okay. Maybe you have a pool and you've tested the pH of your water in your pool. Maybe you've seen somebody test the pH of the water in your pool. Okay. We're measuring the potential of ions. I'm sorry, the potential, the hydrogen ions in solution. Okay. If we don't have water in our pool, we can't measure the pH. And I want you to remember that, because the point being, in our flooring industry, if we don't have water available, we're not going to realize pH of a substrate. Okay. And the reason, well, I'll tell you the reason here shortly. I'll give you a little taste, but we are going to discuss, testing for pH. But the bottom line is, you're typically using deionized water to test the pH of a concrete substrate. We need a liquid there to be able to test the pH of concrete. We can't just put litmus paper on the concrete by itself and get a reading. We'll come back to that in a second. I want everybody to understand the pH scale. Maybe you've heard this. The pH scale numerically goes from 0 to 14, with neutral being 7. But the key thing here is, the scale here. 7 to 8 is 10 times more alkaline. Making that one, that one number jump. If you go from a 7 pH to a 9, it's 100 times more alkaline. You go from a 7 to a 10, it's 1,000 times more alkaline. The scale is logarithmic, and the same goes in the other direction. If you got a 7 and you go to a 5, that's 100 times more acidic. 7 to a 4 is 1,000 times more acidic. The other thing I want to do is kind of give you an idea of the pH of some common materials and substances out there that you guys are all aware of. We'll start off right in the middle. Pure water is neutral pH. It's not acidic, it's not alkaline. Okay. Our blood is neutral pH. Not acidic, not alkaline. You go all the way to the left. Some of the most corrosive things out there, battery acid. Very acidic. The hydrochloric acid in your stomach that breaks down foods so you can digest things, very acidic. Okay. lemon juice or any citrus fruit is acidic. How about Coke or Pepsi? I don't know that everybody knew that Coke or Pepsi, was acidic. And we're going to come back to that shortly. Okay. Anyhow, going to the other side, pH of 14, liquid drain cleaner, caustic soda, bleach, other oven cleaner, very, very acidic. Okay. Hair straighteners, ammonia as well. I'm sorry, I just said acidic. I meant alkaline. Sorry, liquid drain cleaner, bleach, hair straighteners, ammonia, all alkaline materials. Okay. Going back to Coke or Pepsi, okay, uh, corrosion on your battery. Okay, so battery is very acidic. You got different charges there. You'll get corrosion on your terminals. Okay. Actually, that corrosion ends up being, very alkaline. So, I don't know if any of you've done this before, but you've maybe you've cleaned your battery terminals on your car with Coke. Coke is acidic, so it offsets the alkalinity of the corrosion on the battery terminals. Okay. One other thing I'll mention to you, I'm sure we've all taken Tums at one point in time to settle our stomachs. Okay. Or maybe you got acid from your stomach up into your esophagus. We take Tums. If you look on the pack of the Tums, it'll say calcium carbonate. Calcium carbonate is basically limestone. So just to let you guys know, you've all probably eaten limestone at one point in your life. But limestone is on the other end of the scale. It's an alkaline material. So it counteracts the acid in your stomach, to bring things, more, towards a neutral level to, keep that acid from upsetting your stomach and upsetting and hurting your esophagus when you get heartburn. Fresh concrete right out of the truck, wet concrete, very alkaline, 12 to 13 on the pH scale. But over time, as that concrete cures and dries, the surface will carbonate as it reacts with the carbon dioxide in the air, and it drops the surface pH of the concrete down to maybe a 9 or a 10. So that when you put wet adhesives, adhesives made with water, on the surface of that concrete, there's not some sort of adverse pH effect, happening right there because, the concrete typically has a pH of 9 or 10. So now we go back to testing the pH. We talked about it a little earlier. You're basically a chemist preparing a solution here. You're pouring distilled or deionized water on the surface, about a 1-inch puddle. Once you've cleaned the surface, you're taking sandpaper and going back and forth to remove contamination, maybe 20 times or so, and, vacuum up any excess material there and making sure that we're, clean surface concrete. We're not trying to get real aggressive with prep, removing, a 30-second dimension of concrete. We're just trying to make sure that we're at a clean surface of the concrete to test the pH. So in essence, once we're clean concrete, 1-inch puddle, letting it go for 60 seconds, dropping the paper in it, and then comparing it immediately to see what the pH is of the concrete. But again, to realize pH, we have to have a liquid there. So if we don't have a liquid there, we don't have pH. Okay. All right, we're going to transition into adhesives with high RH values. Okay. You see a race going on within in the adhesive industry, and I call it the race to 100 from an RH standpoint. We used to be, in the 80s, 75 was kind of standard at one point, and then we moved into the 80s for a maximum RH for adhesives, and then into the 90s, and now we're pushing 100. I call that the race to 100. The first point that I want you guys to understand is if we have an adhesive with an RH maximum of less than 100. Okay. If the max RH is anything less than 100, whether it's 95, 97, 98, or even 99, the only place that I can use that would be over new concrete, where the RH at the time of installation will never go any higher. What I mean by that is, let's say we have an adhesive that's good to 95, and we test for RH today, and that concrete is 95. Okay, we're suitable to install. But if we're in a situation where that moisture can go higher than 95 at some point in the future, and it does, and there's a failure, then the adhesive manufacturer's washing his hands. It's like, hey, we max at 95, it's at whatever value it is higher than 95, we're not responsible. So I want you to keep that in mind, okay? Max RH, anything less than 100, we got to make sure that RH never goes any higher than that value, that maximum value. The other thing that I want everybody to pay attention to is the pH restrictions, okay? Maybe there's an adhesive that goes to 100 RH. That's fine, but when we get to 100 RH, we have 100 RH is liquid water. If we're at liquid water, then we can realize pH. And if we can realize pH, then it's critical that we look at what the max RH is, I'm sorry, the max pH of that adhesive. So if that adhesive goes to 100 RH and the pH is only 11, well, if we get to 100 RH and we got condensed liquid water and the pH goes to 12 and there's a failure, then that adhesive manufacturer is walking away because the pH was higher than their maximum. So it's critical for everybody to look at pH, what that maximum pH value is of that adhesive for those reasons. Okay, so we know that the adhesive is suitable for a certain RH. We got to ask the question, is the floor covering suitable for RH, for that high RH? Because if it isn't, then we're in trouble as well. Because if the adhesive is good at 98% RH, that basically means that the adhesive is unaffected at 98 RH. That doesn't mean the adhesive is remediating moisture. So that moisture can go through the adhesive. It could potentially affect the floor covering. And if that floor covering is only rated at 80 RH, then you got a failure with the floor covering, and you're in trouble. The adhesive manufacturer saying, hey, our product isn't affected, it's the flooring. And then the flooring manufacturer saying, hey, your RH is way higher than our maximum. So ask the question, that's all I'm saying. Make sure you're on the same page with manufacturer's recommendations. Okay. The last thing I want you to understand is the adhesive itself is tolerating the moisture. It's not remediating it. So you have an adhesive that's suitable for 95, 98, 99. It's basically unaffected. Whereas a moisture mitigation system is unaffected by the moisture, but it's also remediating it or slowing it to a level that's not affecting anything above it. Okay, so understand that as well. Understand that about your adhesive. Now, there's some other types of floor covering out there that have an adhesive on the back side that have a very high RH, such as a 99 RH on the back. And I just want to make sure that everybody understands these products and asks the right questions. Okay, in some cases, the floor covering is sent to a plant where they, apply this adhesive to the back side of the floor covering, and then they ship that back to, the distributor or the job site or the flooring contractor, whatever the case may be. So if you're considering this type of flooring with the adhesive applied by a third party to the back side of the flooring, make sure you're aware of any extended lead times, make sure you're aware of any shipping and logistical issues, and understand the shipping logistics, okay, what that means. So ask the questions, that's all I'm saying. If the adhesive is suitable for 99, ask the question, is the flooring suitable for 99? Ask the manufacturer. Okay. The adhesive is unaffected at 99. Is the floor covering unaffected? Okay. Look at the pH restrictions. Okay. If the adhesive is only suitable for a pH and we get to condensed liquid, the pH could go to 12, 13, 14. If we're outside of the pH recommendations and there's an issue, then the manufacturer is going to say, hey, the pH has exceeded our maximum. So look at the pH and understand the pH and any limitations associated with pH. Epoxy systems, such as the two-component epoxy mitigation systems that are out there on the market, and there's several different manufacturers. I want you to understand that the bond strength of a two-component epoxy to a concrete substrate is much stronger than an adhesive, and that's coming from a manufacturer that not only makes adhesives, we also make epoxy mitigation systems. So we truly understand that. So you have a high RH adhesive and floor covering. Ask the question about mold or mildew. If we get to 100% underneath that floor covering and we got condensed liquid, maybe the floor covering and the adhesive don't fail. But ask the question about mold or mildew. Can things start to grow underneath there? What happens? Do we get staining that's involved due to the mold or mildew growing? Okay, ask the question. This is a big one for me because it's misunderstood throughout our industry. Okay, you could have a floor covering and adhesive system that's a very high RH, maybe even 100% at that point, that can handle liquid water and extreme pH. Okay, your typical patch or leveling products out there on the market are not suitable for that application. Okay, pick a manufacturer. Okay, it doesn't matter to me. Okay, we all make the typical patch and leveling products, and they're all not suitable, for liquid water for extended periods of time. Okay, products have to be formulated to do so. Okay, now, yeah, ARDEX, we have some products like that we formulated for it. There's other manufacturers out too that have formulated products specifically to be used underneath mitigation systems, underneath floor covering adhesives that may go to 100%. Okay, so look into that as well. That's a critical thing that we see everybody overlooking. Adhesive back flooring, okay. Tile and plank is an easy installation, okay. It's just like a peel and stick, drop it in place. Okay, if you're considering a sheet installation, that's a little bit more difficult. Okay, so I would say if you're considering that, play around with it, get comfortable with the installation before you tackle one, because there's certainly going to be a learning curve, with the installation. Okay, and then finally, not just adhesive back flooring, but all manufacturers and different products, different systems, read the warranty. Let's look at what's covered from a warranty standpoint, and let's look at what's excluded. Okay, let's see if it's a prorated warranty. Let's see if it's just replacement of material, or is it replacement of all materials and reasonable labor. Take a look at the warranty and what you're getting, so you have a true understanding. Okay. We're going to move over to slab curl relaxation. When I began the presentation, I mentioned that we're going to talk about slab curl relaxation. This is a process that occurs not terribly often, but can occur, and it's a function of excessive moisture. Okay. This is when, well, let me back up. So concrete can curl due to differential drying. So we have a slab on grade or below grade, and we got a vapor retarder, and that concrete only dries up. That differential drying, top to bottom, can create curl, where the edges of the concrete curl. What we're going to talk about is not only the slab curl, but it's the relaxation that can happen after the fact. So the easiest way to demonstrate this so that you get a true visual understanding of what this is is doing this with a sponge on a plastic laminate countertop. We felt that, if you look at a sponge and we saturate that sponge with water and we sit it on a concrete countertop, that is similar to a freshly poured concrete slab that's sitting on a vapor retarder. Okay. So we place the concrete, we place the wet sponge on a flat surface, a vapor retarder. In this case, our sponge is on a plastic laminate countertop. The sponge can only dry up, it can't dry down. And as it dries, that differential drying will create curl in the sponge, where the edges are curled up higher than the middle. So to further simulate this, we got two sponges. We put them together as if there was a natural joint in the concrete. They're totally saturated. They're on a plastic laminate countertop simulating a vapor retarder. And we just let those dry out. And as you can see, as they begin to dry out, the edges curl. You look at the perimeter, the edges is curled off the sub-base. It's curled off the vapor retarder and the sub-base, which in our picture here, or a video, if you will, is the plastic laminate countertop. Okay. You look at the top of the joint of the concrete, or in this case, our two sponges, and it's open. It's wider at the top than it is at the bottom. So now, I mean, that's what's called slab curl, or I guess in this case, sponge curl. Now we're going to show the relaxation part of it. So I don't know if you can clearly see that, but we put a piece of plastic wrap over the two sponges to simulate putting something on concrete, whether it's a floor covering, whether it's an epoxy coating, whether it's a mitigation system, something on that concrete to stop moisture from evaporating like it was when there was nothing over top of that concrete. So we put the plastic wrap over top of the sponges, and I want you to see what happens. The moisture redistributes throughout that sponge, top, middle, and bottom, and it relaxes. The gap now narrows back together. This happens on projects. I wanted to show you this so that now you got that concept in your mind. Let's go look at the end result, because I would bet that you've seen this at some point in time in your career. So here's two slabs separated by a saw cut. The saw cut, which is to control cracking, did what it was supposed to do. The concrete cracked right at the joint, but the slab is curled a little bit off the vapor retarder and the sub base. So if I put a straight edge across that joint, it'd be teeter-tottering. And what the typical thing that the mechanic would do would be to grind that flat. So they pull out the grinders, they grind everything flat, they patch that control joint, and now they're ready to put flooring on it. So they install flooring, and what happens at this point is the moisture in the concrete, it was greater at the bottom, less in the middle, and the least at the top. It's all going to redistribute, and when it does so, the slab relaxes. And when that slab relaxes after the moisture redistributes, it can buckle the floor covering. Worst case scenario, you got a failure of the floor covering right at that joint. Minimally, it extrudes the patch out of the joint, and you got a bump. These are sometimes called mole runs in your floor covering. Okay, that's not a function of what the floor covering installer did. It's not a function of what the mechanic did as far as an installation. That's a function of the concrete being curled to begin with, and when they put flooring on it, the moisture redistributed, it relaxed, and it relaxed. Here's a cross section of a concrete core that had a mole run in the floor covering. And basically what, by looking at the cross section, what they were able to detail was when that slab was under curl, and when it relaxed, it pushed the patch up out of the joint and created a mole run in the floor covering. Here's a piece of vinyl sheet. It has nice straight line mole runs, and that slab curl relaxation, causing the failure. Extruding the patch out of the joint, out of the control joint, and then you see a mole run. So that leads us to remediating moisture and getting rid of the problems. Approaches to remediation, least expensive at the bottom, going all the way to the top. Yeah, certainly you could just do perpetual maintenance and replace floor covering every month or so, but that's certainly a pain in the butt. You could look at drying the concrete out, but I mean, it's not like you can go order the Binford 5500 moisture eradicator to dry out the concrete floor. So typically not done out there in the industry. You could look at alternative finishes, just leaving the concrete bare, letting the moisture evaporate out into the air. Some people think that we'd want to do stained concrete or a breathable coating, but sometimes there can be aesthetic issues because that excessive moisture drives the salts to the surface, and if you got a decorative floor, you get whitening or like milking out or cloudiness of the sealer because of the salts coming up. The most common thing to do is a topical moisture suppression membrane, a applied membrane, two-component epoxy material, very common. The ASTM standard for that two-component material is ASTM F3010. This is for a two-component membrane forming mitigation for use under resilient floor covering. They're low viscosity materials, typically 100% solids epoxy. In the 3010, it specifies that the perm rating must be at least 0.10 or lower when tested in accordance with ASTM E96. And the reason that we wrote that in the specification, and I say we just because I, as well as many people, manufacturers, independent consultants, are a part of FO6 ASTM committee that built this standard. The reason that we all detailed a perm rating of 0.10 or less is because that's what the minimum standard is for the vapor retarder underneath the concrete. So if we're doing new concrete with a vapor retarder having a perm level of 0.10 or less for stopping ground moisture from coming into the concrete, then we want the same type of epoxy material, resinous material on top of the concrete from a performance standpoint. So that's the reason behind 0.10 or less as the max perm rating of that type of material. Typically blasted with CSP3. So in summary, the key things here, know what type of floor covering is being specified, okay? Understand that floor covering, ask all the questions. Choose the correct adhesive for the installation, okay? Make sure we got the right adhesive, whether it's the RH limit, the pH limit, the type of adhesive it is, whether it's a wet set, pressure sensitive, transitional, look at all those things. Be aware of the RH limitations and the pH limitations. Ask the questions. Test for moisture to know where you are. Ensure the readings meet all of the manufacturer's recommendations. And if necessary, utilize or specify a moisture remediation product, should moisture testing fail. Okay, pretty simple. It's basically just smart, good business practice. Keep those things in mind. I want to thank you for participating in our AIA here, and I will turn it back over to Alyssa for a few minutes.
Yeah, absolutely. So I just wanted to take a second to remind you that if you provided an AIA number during registration, we will be reporting the credits from today's webinar on your behalf. And you should all expect a certificate for today's presentation within a few days. So a few questions before you get into the ARDEX products that kind of correlate back to what we discussed today. And actually, we had a comment that had a helpful hint to remember stalactites and stalagmites. They said stalactite, the C is for ceiling, stalagmite, G is for ground. So
perfect. I learn something new every day.
Exactly. So one question is, how does the slab react to moisture redistribution when an MVRA is used?
I'm not sure I totally understand the question. So how does it react to moisture?
I think in regards to slab curl relaxation, if you're using, an MVRA product, how does it react?
Yeah, so the key thing to do when you get on site is to check the slab, check the joints with a straight edge, because whether if you have slab curl, whether you put a warehouse coating on that slab, a floor covering on that slab, a moisture mitigation material on that slab, the moisture is going to redistribute, and if it's curled, you run the risk of it relaxing. So the key thing here is to go out on site and grab a straight edge, 4-foot straight edge, 6-foot straight edge, whatever, and go around to the joints and just quickly check them. If we're getting, rocking across that joint, then it's certainly curled, and the risk is that it could ultimately relax. So the point being to all this is raise the red flag, check the joints, see if they're curled. If they are, you got to make it known to the general contractor, and the owner, because then we got to look at plan B on what we're going to do here. You're raising the red flag because you don't want it to come back. You don't want it to come back to the flooring contractor if it does relax and extrude material out of the joint and they see something. It's not the fault of the flooring contractor. So do the quick straight edge testing to see if it rocks and raise the red flag. Hopefully I answered your question that you were asking.
Can you address silicate curing compounds used in construction and their effect on adhesives?
Certainly. So yeah, there are silicate curing compounds out there. Silicates have been around for 100 years, literally like 100 years, over 100 years. Sodium, potassium, newer technologies or lithium. And without trying to get too technical into the chemistry of them, they react with the free lime in the concrete to help densify the surface. And in densifying the surface, they keep moisture in the concrete longer, not allowing it to evaporate as quickly so that the proper curing and hydration of the concrete occurs. So having said that, if they're applied correctly in accordance with manufacturer's recommendations to include proper neutralization, proper rinsing, and proper drying, we should not, and proper removal of any excess silicates in accordance with manufacturer's recommendations, there shouldn't be any foreign material there to adversely affect the adhesive. Now that's easier said than done, but I will say this, if we have no foreign material there to affect the adhesive, then the other thing that can cause the problem is the density of the surface. So if we change the density of surface, we change the absorbency of the surface, which means your typical 16th inch square notch trowel over that concrete and typical 10-minute open time may not apply anymore. So it's almost like the concrete has a non-porous surface, and it could be detrimental to the adhesive only because the adhesive wasn't allowed to dry properly. So, the flooring contractor basically thinks it's regular concrete, uses the same notch trowel, same open time, but the moisture and the glue can't get into the backing of the flooring because maybe it's a vinyl back product. It can't get into the pores of the concrete because it's been treated with a silicate. And then the adhesive never develops the strength needed for that flooring to perform. So if a topical silicate's been applied, certainly check with your adhesive and flooring manufacturers and get their recommendations. And another good thing to do is just to be safe is do test areas. We're all, as a manufacturer, we are always an advocate of test areas just to see how things are going to perform in that specific environment, especially when things might be a little different or you have a different product that's used in the equation here. Hopefully that was helpful.
And then would you recommend an epoxy or urethane moisture vapor for all high relative humidity?
Well, I'll say this, the industry standard for resilient flooring is F3010, and that standard details the use of a 2-component membrane forming mitigation system. So there's an industry standard that makes that recommendation. And certainly from my experience, and looking at the industry itself, and there's multiple manufacturers that make two-component resinous materials. Those products have a tremendously long, successful track record in our industry for mitigating moisture. They're typically all up to 100%. So if you get condensed liquid, there's no adverse effect. They're typically all 14 pH. There's no adverse effect with pH.
Great. Well, in fear of running over, why don't we continue with the products? And then any questions that we did not get to, we will follow up via email with you after the webinar has concluded.
Sounds good. And I apologize, we're running a little bit over here. We're going to go through some of the ARDEX products here, just to briefly give you an idea of what we have in our product line, but I'm not going to take up too much more of your time. I appreciate the time you've given me thus far. Certainly as a reminder here, certificates for today's webinar will be distributed via email early next week. If you provided your AIA number registration, we'll put those credits on your behalf. So, okay, so we certainly in the flooring adhesive business, W.W. Henry is one of the largest and oldest adhesive companies, in North America. We acquired them from Armstrong back in 2000, so they've been a part of ARDEX, for 20 years now. We pride ourselves on the quality and innovation, and certainly the service and field support out there in the industry. We have a variety of different adhesives for many different applications. Even ceiling tile, for example. But these are our Elite 8, as we call it, adhesives that we have out there. 440, a code-based adhesive, has been the industry standard for many, many years. We have a acrylic urethane wood adhesive, waterborne, but very, very high solids, nearly 90% solids, very easy to work with, 1171. Multi-purpose adhesive, 256 for carpet and felt back sheet. Another product's been around for a lot of years. 351 for carpet. That product's been successful and around for a lot of years. That's our carpet adhesive, waterborne SBR. Henry 430 Clear Pro for VCT. That's also a waterborne SBR adhesive that's had a tremendous track record, been around for a lot of years. Some of the newer technology, acrylic type adhesives, and we will mention a couple of these in the presentation, but 650R releasable, typically for vinyl back carpet tile, and some cushion back plank and tile. But we have two brand new high RH products, 647 pressure sensitive roll-on, and 695, which is a wet set or pressure sensitive adhesive. One thing I want to make known to you is 647 and 695 does have a 99 RH, does have a pH of 11. However, we qualify that. For slabs on grade, we have to have an intact vapor retarder so that we don't have excessive moisture, creating this moisture level in the concrete to go to 100% condensed liquid. So today it's 99. But you've got to have an intact vapor retarder on grade or above grade slab with no other moisture sources. And we're not going to do this over renovated concrete. We're not going to use these adhesives over a slab that's on grade and 20 years old, because if we're getting high RH with a slab that's 20 years old, that's certainly not water convenience in the concrete from when it was placed. That's some other source of moisture. 695, brand new adhesive for us, been out for about a year or so. 99 RH, pretty long working time, 4 hours. Dry to the touch is a pressure sensitive. You have 4 hours to drop the flooring in. Can also be used as a wet set. Outstanding bond strength, trial applied type adhesive, basically for all types of vinyl products. Pretty killer adhesive. It's complementary adhesive. Is 647 Plum Pro. We call it Plum Pro due to the color. We pigmented on purpose the beautiful plum color you see in the picture there, so that we can see where we're going, we can see where we've been, and you're rolling this on It's almost a matter of minutes in most cases, 5-10 minutes, and it goes dry to the touch, and you're dropping in LVT, LVP, vinyl enhanced tile, VCT, sheet. You open floor up the traffic immediately. With a pigment, like I said, it's easy to see where you're going and where you've been. There's no holidays, and it's a 99 RH adhesive as well. New technology for us, pretty happy and thrilled with this technology. Lastly, 650R 95 RH. It's a permanent installation if it's a wet set, but as a dry to the touch installation, pressure sensitive, that's releasable. So vinyl back carpet tile, drop it in a pressure sensitive install, keeps the tile from sliding laterally. Come back 7 years from now and pull out a carpet tile, drop a new one in type product. High RH subfloor prep products. Okay, we have a full line of mitigation products. MC Rapid is our 2-component 100% solids epoxy. Tremendous experience and success with this material. It actually exceeds ASTM F3010. It has a permeability of 0.06 perms via E96. We have 2 other materials called VR98 and PU50 that are 98 RH products. The VR98 is a waterborne product, 2-coat material used as a primer for our self-leveling. So you can use this on new concrete up to 98 RH and then use it as the primer for the self-leveling. The PU50 is a urethane material, cures via moisture, very easy to apply, and it's better suited for applications where you may not have the greatest drying conditions. So higher humidities and no airflow type applications. So we got one for every scenario, but MC Rapid is used the most frequently. Okay, full line of self-leveling materials. Certainly K15 has been around since the mid 70s and the most widely specified self-leveling product out there. We got some newer technologies, K13 that we're going to discuss. We have a reactivatable K10, our workhorse V1200, and our entry-level V1000. A couple of specialty products, K60, which is a mixed with a liquid, low tension material. We'll touch on that. And K22F is for fixing gypsum substrates. It has fibers in it, makes it extremely flexible, and then very high strength properties. But the K13 is our first dual water ratio, used over virtually any surface, any substrate. Lower water ratio for standard flow, but getting into high flow where you want to go 1/8 inch over the surface, we go to the high water ratio. It's an additional 8 ounces of water. So dual water ratio is critical for this material. Great coverage, great flowability, suitable at 99 RH. Step down to V1200, that's our workhorse, concrete, terrazzo, non-porous surfaces, substrate, epoxy substrates. Great flow properties and heal properties with this material, most floorings in 24 hours. It's a lot more cost effective than K13, and that's why we consider it our workhorse. Does a majority of the work, the heavy lifting for us. K60 is a pretty unique material. It's a ARDEX UK technology, original formula dating back to the 70s, and has been improved along the way. But no water with this. You're mixing it with a gallon of latex, and applying it, spreading it, and smoothing it. A lot of goodies in this. You got the gallon of latex admixture. No priming. It'll stick to a piece of glazed porcelain, glazed ceramic, or porcelain tile without a primer due to the goodies in it and the acrylic latex. Very good heal properties. You can put this down to 1/8 of an inch. 100% resistant to moisture. So we can use this under MC Rapid. It can go to liquid water underneath it and has no adverse effect. And we actually have a skim coat product that's a complementary material to the K60 that we'll mention here that can also go to 100% liquid water. From a leveling standpoint, whether it's your high RH adhesives or under a mitigation system, this is our leveling product that can go to liquid water with no adverse effect. In essence, we have a variety of type of patching materials, both interior, exterior, both as underlayments and as toppings, both for skim coating and for ramping, sloping, and screeding. MRF is a unsanded skim coat product. It's like the industry standard ARDEX feather finish, but formulated to go underneath mitigation systems, underneath the high RH floor coverings. It is the complementary product to K60. So you got K60 self-leveling at 100%. You got MRF at 100%. To put this into perspective, you could use MRF outside. It could be indefinitely damp in an exterior application with no adverse effect. Is unsanded, easy to trial out for a true skim coat material, and for those high RH floor coverings and adhesives. In essence, I also want to make known to you that if you don't know that, going back to the acquisition of Henry, we created System 1, where we took Henry Adhesives and ARDEX patch and leveling products and created System 1. 20 years using system products together. You have some adhesives and some leveling products as a system where you get a 20-year warranty. We also have full line of setting tiling installation products that are part of System 1 too, that actually some of them go up to 25-year warranties doing leveling products and setting materials and grouts as a system warranty. The bottom line here though, we're an extremely versatile company. Most of us think of us as the subfloor prep company, patching and leveling company, but with the acquisition of Henry, we're an adhesives company. We're certainly in the moisture control business. I just mentioned to you about the complete line of tile and stone installation products, and oddly enough, when you look at the 40 some ARDEX companies globally, and you look at what they sell day to day, technically we are a tile and stone installation products manufacturer. Even though in North America and in ARDEX, for ARDEX Americas, we're considered the leveling company. Complete line of tile and stone installation products. Exterior products for concrete repair, both from a cosmetic standpoint and from a structural standpoint. And we've led the industry from a decorative patch and leveling standpoint for a lot of years, dating back into the 90s as a manufacturer, but there were a lot of contractors doing decorative products with our self-leveling products back into the 80s with integral color and decorative saw cuts and topical stains and logos and things like that. So, if you weren't familiar with some of these other product categories that we've had under our line and have had so for years, jump on our website and check things out. And if there's an application that interests you, reach out to us and let us know how we can help you. Bottom line here, I want to thank everybody for your time today. We appreciate you taking some time out of your schedule to spend a little time with us. We hope this was helpful, and certainly if we can help you out in any way or answer any further questions about future applications or anything that was said on this during this presentation, please let us know. Thanks again.
Thanks, everyone. Thanks, Seth. Have a great day.